We're going to extend the concept of confidence intervals to other statistics. We've done confidence intervals around means by thinking about the standard error of the mean and the spread of the sample means. And in this video, we're going to talk about confidence intervals for proportions. Proportions are simply a binary variable. What percent of people have a characteristic or don't? So for example, what percent of baseball players are left-handed? This goes back to what type of variable do we have? You're either left-handed or you're right-handed. There's no, well, there is an in-between. It's amphibious, right? But we can conceptualize this variable as being a yes, no, left-handed or right-handed. What is the prevalence of cigarette smoking? We either smoke cigarettes or you don't. Well, that's not the full story. We've actually seen that you can define cigarette smoking in a lot of different ways. But again, for this variable here, you're either a smoker or not. You either have HIV or you don't. You either have erectile dysfunction or you don't. Now, notice for each of these questions that we have some sort of population. Professional baseball players, men and women in Wisconsin, females this age, males in the US, right? So how do we estimate that population proportion? Well, same thing we did before. Number one, you go out and you get a sample. Ideally, some random, unbiased, independent sample. Then you take your sample and you calculate the statistic. Before, all the statistics we did were means. But now we can say, what's a proportion? Remember, a statistic is a number that describes your sample. So just count up the number of people who have a given characteristic, divide by the number of people you have in your sample, and there you go. That's your statistic. But we need to remember that had we taken a different sample, we get a different collection of people, and we get a different statistic. So that proportion resists the temptation to think of the proportion as a real number. It's just a random instance of bubbling up of this is what I got in my sample. So that proportion has a standard error. It bounces around randomly by chance, and the standard error quantifies how much it bounces around. Now, I want to remind you of the standard error of the mean. Remember what that was? We said we take the standard deviation, or sigma, and we divide it by the square root of n. Now, when we have a proportion, sigma doesn't really make sense. There's no standard deviation or spread of a proportion. Either you have it or you don't. But when we calculate the standard error of the proportion, here's the formula that we use. And take a look at this closely. What's in the bottom? N. And technically, the square root of n. And what's in the top? Well, here it's the proportion, or the percent, times 1 minus the percent. So it's kind of like some sort of measure of spread, like how spread out is this thing? Is it something that's 50-50? Or is it something that's 10-90? And that'll dictate what's in the numerator. So if you blur your eyes enough, these two formulas are kind of the same sort of deal. A measure of how spread out is this thing divided by the square root of the sample size. So collect a sample, calculate your statistic, calculate the standard error of that statistic, and then make a confidence interval. What was the confidence interval for the mean? It was x bar plus or minus 1.96 times the SEM. And what do we see for the confidence for a proportion? Sorry, I got excited. Is the statistic plus or minus 1.96 times, there you go, the standard error of the proportion. So I think it's important to try to think about, what do I know? What do I understand? And when I try to get into a new situation, how can I take that knowledge and hang the new information on top of it? And if you look at this, the CI for this statistic, it's really the same thing that we did for the CI for a mean. Let's walk through a quick example. What percentage of baseball players are left-handed? Take a random sample. N equals 59. Calculate the proportion. 15 divided by 59 is 25%. I don't know, that seems high, Tybor. That might not be a random sample. Most people aren't left-handed. Well, these are baseball players, and this population being left-handed is an advantage. When my son was born, over his crib, I hung a little baseball, and I hung it on the left side, so he could only hit the ball with his left hand. And, of course, he's right-handed. Didn't work. So we calculate that proportion, and then we calculate the standard error. And then we plug it in with our multiplier, and we make our confidence interval, and it's something like this. Report the confidence interval in parentheses with a comma in between. And then we are 95% confident that the true percentage of left-handed baseball players is between this and this. Why is that word true? What is that? That's just to emphasize now that when we say true percentage, we're talking about in that population. The true percentage is this. Now, what do you think about that CI? How does it make you feel? It's kind of wide. How could we make it narrower? Well, you can't change the numerator of the standard error. That's fixed, right? That's sort of what's going on in the population. But you can change your sample size. So as your sample size increases, the confidence interval gets smaller. And we say that this is more precise. You have more precision. You can hone in. You can hone in on the truth a little bit better.